Welcome to this lesson on logarithmic equations. In this lesson, we will solve more complex equations that require the use of logarithm properties. Take a look at this equation below. Before we get started, consider the steps that you might try and take in order to solve it. Consider our properties of logarithms we learned previously. Some thoughts you may have had is that the equality property is related here, because we have a log of base 10 on each side. However, we notice that there is a 2 or coefficient in front of the log on the right side of the equal sign that might get in the way. So you may be thinking of an exponent property of logarithms. So now let's look a little closer. Take a look at these two provided solutions for the equation. Which one do you think is correct? You would have noticed that solution number 1 gives one result of x equals 4. And solution number 2 finds two results of 4 and negative 2. You may have guessed that solution number 2 should be correct because there's two solutions that are found, whereas solution number 1 did not find x equals negative 2. But let's take a closer look as to why. So solution number 2 is correct. Solution number 1 omitted one of the possible answers. It has to do with the power property we mentioned. Both solutions use the power property for logarithms. On solution number 1, the property was used in the expanding fashion because the squared came to the front as a coefficient of 2, and then those 2's were canceled out. In solution number 2, on the right side of the equal sign, the property was used more in the condensed version where the 2 was brought up to be an exponent on the 3. This property can only be used to expand when you know that the argument is positive with the logarithm. In this case of solution number 1, we don't know that x minus 1 is positive here. The property was used to condense in solution number 2, which allowed for both solutions to be found. So you should be focusing on using the properties to condense rather expand when possible. So now let's take a look at a few examples. Remember our methods from before. Which method would you apply to this equation? Hopefully you recognize rather quickly we should use method number 4. We have the logarithm property involving subtraction. So if we recall, subtraction is related to division. So we're going to condense these two logarithms so that there's only one log and write it as division. And continue to solve. Remember from a previous lesson we need to eliminate this log. We can use the exponential base of 10 on each side to cancel out the log. So we're left with x squared equals 100. We can take the square root on both sides and find two results. X equals plus or minus 10, but we know that we have to check if it's extraneous. So we're going to substitute 10 and negative 10 into the arguments. So in this case, neither are extraneous because we got a positive result. Okay, let's take a look at another example. Here is a log equation that someone solved, but there is a mistake. Can you identify what the mistake would be? So it appears as though people canceled out the logarithms and converted the addition to multiplication, but the logarithm was omitted for the rest of the problem. So we are going to use the property that converts addition to multiplication. So we're going to condense. Therefore, x plus 5 and x minus 5 will be multiplied. To get rid of the log first before we do that, let's use an exponential base of 3 on each side. So 3 squared will give us 9 on the right. Now from our previous algebra learning, we can use a FOIL method or box method to multiply this out and combine like terms. We can continue to solve using methods we've learned. So we cannot do the square root of 34, but we can approximate it. And again, we must check and see if it's extraneous. So we're going to plug positive and negative 5.381 into the arguments and see if we get a value greater than 0. So for the first one, if we plug in positive 5.381, we get a positive result. It's not extraneous. But if we plug in negative 5.381, we do get a negative value. So that answer is extraneous. Let's take a look at one more example. What would be your first step in solving this equation? If it helps, think back to our discussion at the beginning. You may be thinking of the exponent property. So we need to condense using this property by bringing our 2 and making it a squared. Now we can use the equality property and drop the log base 5s. And again, at this point, this becomes more of an algebra question. We can square root each side and get x minus 2 equals plus or minus 6. So x minus 2 equals positive 6, so we get the result of 8. X minus 2 equals negative 6, which we get the result of negative 4. So once again, check and see if either of these are extraneous. Negative 4 is extraneous because when we plug it into x minus 2, we get a negative value. Now practice your learning and see me if you need any help.